Section 3.3 in Chapter 3 is titled Mechanical Work. And mechanical work is done whenever force moves a distance d in the direction of the force. And the force is given by an equation. And let me share a little screen here and we'll look at this. And of course, we're talking about work in the sense of, what we study in physics and, that definition of work, force applied over a distance. Okay, so what we're looking at here is, this is on our page 51 still. Well, actually, this slide is on page 52. But the equation, and if we were in class again and we were working through this, what we would do is we would be making our equation sheet, and this would be equation 3.3, and it would be work is equal to force times distance. Again, we're trying to stay in the world of SI units, so that when we're talking about this particular equation, work will be given in joules, force in newtons, and distance in meters. Best way to really understand that is to apply this equation to a problem. So he says in this particular problem, says that we have a mass of 50 kilograms here, and we're going to lift it to a height of 10 meters here, okay? And we want to calculate the work done in moving that 50 kilogram thing 10 meters against the force of gravity. So that's what we're working with here. And we have to work with a combination of our formulas that we've used so far. And the first thing that we need to do to be able to work this problem is we need to convert the mass to newtons. So we're going to use our equation that says force is equal to 9.8 times the mass, 9.8 times a mass of 50 kilograms is going to be equal to 490 newtons. 490 newtons will plug into our equation for work. So let's say we're going to go here. And so work is equal to 490 newtons. And the distance is in meters, and it's 10 meters. So the work done for this particular situation is 4,900 joules. Now we will use this as another foundational equation as we move forward with this, but this is our definition of mechanical work, section 3.3.